And so my first topic with respect to this was not death, but obesity. And it had become trendy to speak about the obesity epidemic. And along with my collaborator, James Fowler, we began to wonder whether obesity really was epidemic, and could it spread from person to person like the 4 people I discussed earlier. So this is a slide of some of our initial results. It's 2,200 people in the year 2000. Every dot is a person. We make the dot size proportional to people's body size. So bigger dots are bigger people. And in addition, if your body size, if your BMI, your body mass index is above 30, if you're clinically obese, we also color the dots yellow. So if you look at this image right away, you might be able to see that there are clusters of obese and non-obese people in the image. But the visual complexity is still very high. It's not obvious exactly what's going on. In addition, some questions are immediately raised. How much clustering is there? Is there more clustering than would be due to chance alone? How big are the clusters? How far do they reach? And most importantly, what causes the clusters? So we did some mathematics to study the size of these clusters. This here shows on the y-axis the increase in the probability that a person is obese given that a social contact of theirs is obese. And on the x-axis, the degrees of separation between the 2 people. And on the far left, you see the purple line. It says that if your friends are obese, your risk of obesity is 45% higher. And the next bar over, the orange line, says if your friends' friends are obese, your risk of obesity is 25% higher. And then the next line over says if your friend's friend's friend, someone you probably don't even know is obese, your risk of obesity is 10% higher. And it's only when you get to your friends' 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 friends that there's no longer a relationship between that person's body size and your own body size. Well, what might be causing this clustering? There are at least 3 possibilities. One possibility is that as I gain weight, it causes you to gain weight, a kind of induction, a kind of spread from person to person. Another possibility, very obvious, is homophily, or birds of a feather flock together. Here, I form my tie to you because you and I share a similar body size. And the last possibility is what is known as confounding, because it confounds our ability to figure out what's going on. And here the idea is not that my weight gain is causing your weight gain, nor that I preferentially form a tie with you because you and I share the same body size, but rather that we share a common exposure to something like a health club that makes us both lose weight at the same time. And when we studied these data, we found evidence for all of these things, including for induction. And we found that if your friend becomes obese, it increases your risk of obesity by about 57% in the same given time period. And there can be many mechanisms for this effect. One possibility is that your friends say to you something like, they adopt a behavior that spreads to you, like they say, let's go have muffins and beer, which is a terrible combination. But you adopt that combination, and then you start gaining weight like them. And another more subtle possibility is that they start gaining weight, and it changes your ideas of what an acceptable body size is. And here what's spreading from person to person is not a behavior, but rather a norm. An idea is spreading. Now, headline writers had a field day with our studies. I think the headline in the New York Times was, are you packing it on? Blame your fat friends. What was interesting to us is the European headline writers had a different take. They said, are your friends gaining weight? Perhaps you are to blame. And we thought this was a very interesting comment on American, kind of self-serving, not my responsibility kind of phenomenon. Now, I want to be very clear, we do not think our work should or could justify prejudice against people of one or another body size at all. Now, our next question was, could we actually visualize this spread? Was weight gain in one person actually spreading to weight gain in another person? And this is complicated because we needed to take into account the fact that the network structure, the architecture of the ties, was changing across time. And in addition, because obesity is not a unicentric epidemic. There's not like a patient zero of the obesity epidemic. We find that guy, there was a spread of obesity out from him. It's a multicentric epidemic. Lots of people are doing things at the same time. And I'm about to show you a 30-second video animation that took me 5 years, me and James, 5 years of our lives to do. And so again, every dot is a person. Every tie between them is a relationship. And we're going to put this into motion now, taking daily cuts through the network for about 30 years. The dot sizes are going to grow. You're going to see a sea of yellow take over. You're going to see people be born and die. Dots will appear and disappear. Ties will form and break. Marriages and divorces. Friendings and defriendings. A lot of complexity. A lot is happening. just in these 30-year period that includes the obesity epidemic. And by the end, you're going to see clusters of obese and non-obese individuals within the network. Now, when I looked at this, it changed the way I see things. Because this network that's changing across time has a memory, it moves, things flow within it, it has a kind of consistency. People can die, but it doesn't die, it still persists. And it has a kind of resilience that allows it to persist across time. And so I came to see these kinds of social networks as living things that we could put under a kind of microscope and study and analyze and understand. And we used a variety of techniques to do this, and we started exploring all kinds of other phenomena. So we looked at smoking and drinking behavior, and voting behavior, and divorce, which can spread, and altruism.